Good morning, or good whatever it is happens to be where you are at this time. It's good to be back because I've had a long radio silence. So let's get down to it right away. We have this awesome limit, which you can see up at the top of the board. Uh, Limit as x goes to zero of this rational function. C is not allowed to be zero. So we've got, it's a limit as x goes to zero, where c is some constant, some real constant that's not zero. Now we're gonna do this in two different ways. We're gonna do this as if you haven't had any calculus yet, although you might have. I mean, you've got the idea of limits, but you haven't done any derivatives. And then we're going to do it like at the beginning of a calc one, and then we're going. But before we do that, we're going to do it like at the end of a calc one. So we're going to do it with derivatives. So yeah, that didn't make any sense. Okay, if you're watching this in the replay, pause it and give it a try. And we're going to look at two different ways of doing it. So first, we're going to do it with derivatives, okay, as if we do know some calculus. And so we're going to do that. And here, I'm just going to lock that there so I don't accidentally mess it up. So remember, I mean, the first thing that you want to do, the first thing you want to check is, can x even equal zero in this? Like, what happens when we make x equal zero? I mean, we've got to do the obvious thing here, okay? Sometimes the obvious is not what we remember. So we're going to make x zero. So let's make x, that's going to be zero, and that's going to be zero. Now, we've got zero on the bottom. We don't know if that means that the limit doesn't exist, if it goes up and down forever. It could be, infinity, but let's see what we got on the top. Then we have 1 plus our constant times 0 minus 1, and that's a cube root. And that ends up being, the cube root of 1, which is going to be 1 minus 1 all over 0, and that equals 0. So it's indeterminate. Oh, okay, the top is 0, sorry, the bottom is 0 too. So it's indeterminate. This is a fancy way of saying we're not done. We don't have an answer that means anything yet. Okay, so now, fast forward, we're back at the end of the calculus course. When we see something like this, we're going to think, oh, L'Hopital's rule. Let's just take the derivative of the top and the bottom and see what we get. Okay, so we're going to do d by dx. And if you don't know derivatives, that's okay. We're going to do this without it pretty soon. And I'm going to rewrite this baby in terms of an exponent minus 1 all over x. Okay, and we're taking the bottom derivative too. So we're not differentiating the whole thing. We're taking the derivative of the top and the derivative of the bottom, and that should give us, well, that may give us a solution, and it will. So derivative of this, well, the derivative of the bottom is easy, isn't that? Isn't that easy? I mean, that's just 1, so which is great. So that means if we can differentiate the top, we're on a good track. So let's do that. 1/3 1 plus cx to the, I'm going to subtract 1 from this, so to the negative 2/3. Okay. Times the derivative of what's inside, which is times cx. Okay. And then derivative of 1 is nothing. So this thing up here is what we end up with. Let's simplify it. Sorry, that x shouldn't be there. I'm looking at this and I'm going, that's just all times c. Okay. So let's rewrite this. That equals, it's all going to be denominator except for this c. So c all over we'll put this 3 down here. 3 times 1 plus cx to the 2/3. And the thing is, now we'll plug in the 0. Now we'll plug in the 0. And that means this becomes 0. So this becomes 1 to the 2/3, which is just 1. So we're going to cross that whole thing out, and we end up with c over 3. So that is your derivative with what you call L'Hopital's rule. A la L'Hopital. And if you get this at the end of your Calc 1, on your Calc 1 final, you're probably going to do this because you're going to go, oh, I get to do L'Hopital's rule. And it's really cool. So fine. But now we're going to do it as it appears in the textbook, from Stewart's textbook. It actually appears before he even has stuff about the rules for differentiation. It's just he's dealing with limits. And so now we're going to do it from the point of view of I don't know how to take different derivatives. So let's do it. And I got to get rid of that L'Hopital word. It's sliding around. Stop it. Behave. Okay, come on. I'm just going to erase you. I'm just going to erase you. Okay. Okay, so now, same thing. We've got 0 over 0. Okay, so we need to do something. So what we're going to do here is we're going to take, I'm going to erase those zeros though. Okay, we're going to take this bit here, and we're just going to do a substitution. We're going to say that's t. Okay, and then we're going to remember that this is t, and we'll have to go backwards once we've solved it with t, because it's going to be something that we can solve with t. So what do we got here? We've got t minus 1. So I mean, what are we saying here? We're saying this 1 on top, and actually we've got x on the bottom. We have to figure out what that is. What we're saying here is that t cubed, that's an awful t. We're saying that t cubed equals 1 plus cx. That's what we're saying. And so then when we take the cube root, we just end up with t. This whole thing is t. But now we've got to define x. I mean, what is this? Well, if t cubed is 1 plus cx, we'll work that out over here. Then t cubed minus 1 equals cx. And so t cubed minus 1 over c equals x. So this thing here, that's what we're going to put up here. So we've got t cubed minus 1. And then instead of putting all of this over c like this, let's just put the c up here. Okay, and now we've got an expression. And I erase all this business down here. And now the question becomes, is this factorable? And indeed it is. I mean, this thing down here, and I think there was somebody who made a comment, and I'm wondering if this is where he was going at, because he was talking about, he was talking about the difference between cubes, and I think that's probably what he's looking at here. So we're going to have c of times t minus 1 all over, and we can factor out t minus 1 out of this thing on the bottom, and we end up with t squared plus t plus 1. I think that's it. I'm not messing that up, am I? No, that's good. Okay. And now, what do we do with that? Well, we're going to cancel out the t minus 1s. Okay. And then we're going to reevaluate this limit in terms of t. As I said, we have to go back and deal with our substitution. And let's have a little coffee here. Okay, so here's our thing over here in the corner. I hope you can see it. We were doing as x goes to 0, right? So that means we're dealing the limit. What happens when I put 0 in here? Then this all gets out. So we're doing the limit as t cubed goes to 1, and because we're dealing with real numbers, we can simplify that to t goes to 1. Okay, beautiful. So now we can plug 1 into all of this. So this becomes 1 squared, which is 1, plus 1, plus 1, which is, of course, 3. So our limit is c over 3, which is exactly what we got when we used the derivatives, but we got it without it, which is so cool. That's all I have to say. Thank you so much for watching, and like and subscribe and all that other stuff. And I'm hoping to do some more math videos. I'm hoping to be back at it soon. So I just had to dive in. Cheers, and remember, I don't have a slogan, so I'm just going to say bye. Cheers.